Hello everyone. Mechanical properties of fluids for surface tension. In this video, I'll be talking about the topic surface tension. In this figure, we can see a pin floating on a glass of water. This is a consequence of surface tension. Now introduction. The other consequences of surface tension that we can observe in our everyday life are the water droplets that appear on the leaves of plants. It is due to surface tension that water sliders are able to walk on the surface of water. Now we can see what actually surface tension is and what is the cause of this phenomenon. Surface tension is related to free surface of liquids. We all know that liquids have got a definite volume and no definite shape. Hence, they acquire a free surface when poured into a container. The surfaces possess some additional energy, and this phenomenon is called surface tension. Surface tension is on account of the extra potential energy possessed by the liquid molecules at the surface of the liquid. Now, surface energy and surface tension. This is a figure showing the liquid molecules. In the first figure is a molecule which is surrounded by other molecules on all sides. It experiences same cohesive force surrounding molecules. But in the case of a molecule on the surface, the molecule on the surface only experiences a cohesive force from the interior molecules, and hence the potential energy of the molecules at the surface of the liquid is much greater, and hence the surface energy is much greater. So surface tension has been well explained by the molecular theory of matter. According to this theory, cohesive forces among liquid molecules are responsible for the phenomenon of surface tension. The molecules well inside the liquid are attracted equally in all directions by the other molecules, while the molecules on the surface experience an inward pull. This is what makes the surface behave like an elastic membrane. Thus, a network is formed against the inward pull in order to move a molecule to the liquid surface. It results in a greater potential energy on surface molecules. In order to attain minimum potential energy and hence stable equilibrium, the free surface of the liquid tends to have the minimum surface area, and thereby it behaves like a stretched membrane. Now we shall take the case of a thin liquid film ending in a bar which is free to move between two parallel guides. Now consider that a force F is applied on the bar and the bar moves a distance d. Then work done by the applied force is given by force into displacement. If the surface energy of the film is S per unit area, the extra area is 2dl. Now a film has two sides and the liquid in between. So there are two surfaces and the extra energy is S into 2dl is equal to F dot d. This is as a consequence of conservation of energy. And from this we get S, which is the surface tension, is equal to F by 2L. So surface tension is the surface energy per unit area of the liquid surface, or it is the force per unit length. Now liquid surface interfaces. In order for surface tension to happen, it requires interfaces. Surface tension is a force per unit length or surface energy per unit area, acting in the plane of the interface between the plane of the liquid and any other substance. It also is the extra energy that the molecules at the interface have as compared to molecules in the interior. At any point on the interface, besides the boundary, we can draw a line and imagine equal and opposite surface tension forces S per unit length of the line acting perpendicular to the line in the plane of the interface. The line is then in equilibrium. Now we can see the concept of angle of contact. The surface of liquid near the plane of contact with another medium is in general curved. The angle between the tangent to the liquid surface, which is curved at the point of contact, and solid surface inside the liquid is termed as the angle of contact. It is denoted by theta. It is different at interfaces of different pairs of liquids and solids. The value of theta determines whether a liquid will spread on the surface or a solid, or it will form droplets on it. Based on the value of theta, we can specify whether a liquid wets a solid or not. Now we can see when the angle of contact is obtuse, droplet will be formed. This is what is observed in the case of water on a lotus leaf, where it forms a droplet. In this case, SLA is the surface tension of the interface between liquid and air, and SSL is the surface tension of the interface between the solid and the liquid. In this case, the surface tension between the solid and liquid SSL is much greater than SL. Hence, it takes much greater energy to form a solid liquid surface, and hence it is hard to wet a solid. This is the case when the angle of contact is obtuse. When the angle of contact is acute, the water will spread. This is observed in the case when water is thrown on a plastic sheet. In this case, SLA, which is the surface tension of liquid air interface, is greater than SSL, which is the surface tension between the solid and liquid interface. In this case, the SSL is reduced so that the water wets the solid much easily. Now, drops and bubbles. These are also a consequence of surface tension. Drops and bubbles are spherical due to surface tension if effects of gravity are neglected. The pressure inside a spherical drop is more than the pressure outside. A drop has only one interface. Now we shall consider the case of bubbles. A bubble has got two interfaces, that is air liquid and then liquid air. The liquid forms a thin film in the case of a bubble. Now work done in blowing a drop from a radius R1 to R2 is W is equal to S into 4 pi into R2 square minus R1 square, where S is the surface tension. In the case of a soap bubble, the work done is twice as it has got two free surfaces. Now capillary rise. Capillary rise can be explained based on the surface tension. Capilla in Latin means hair. When a very thin glass tube is immersed in water, we can see that the water rises in the tube against gravity. This is as a result of surface tension of water. The one consequence of the pressure difference across a curved liquid-air interface is the effect that water rises up in a narrow tube in spite of gravity. Now the contact angle between water and glass is acute. Hence, water wets glass. Thus, the surface of water in the capillary is concave. This means that there is a pressure difference between the two sides of the total surface. Since the surface of water in a capillary is concave, capillary rise is observed. While in the case of mercury, the surface of mercury inside a glass tube is convex, and hence a fall in the level of mercury is observed. That is Pi minus P0 is equal to 2s by r. That is 2s by a sec theta is equal to 2s by a into cos theta. Now the pressure of the water inside the tube just at the meniscus, that is the air-water interface, is less than the atmospheric pressure. That is given by P0 plus H rho g is equal to Pi is equal to Pa. Here H is the height by which the water has risen in the capillary tube. G is the acceleration due to gravity. From these two equations, we get H rho g is equal to 2s cos theta by A, or H is equal to 2s cos theta by A rho g. Now, we can see the action of detergents. The cleaning action of detergents is on account of surface tension. Detergents are surfactants. That is, surfactants are used to angle of contact so that it becomes, and hence water is able to wet oil and dirt, which it otherwise cannot. Soap molecules are hairpin shaped molecules having two ends. The one end attracts to the water while the other end attracts to the dirt and oil or grease. That is, soap molecules have got a hydrophobic as well as a hydrophilic end. The hydrophilic end is the end which attracts water, while hydrophobic ends attracts to dirt. Now, when detergent is added, the inert waxy ends of its molecules are attracted to boundary where water meets dirt. Inert ends surround dirt and the platter dirt now be dislodged, say by moving water. By altering the angle of contact of water by using surfactants like detergents, it is possible to wet oil and dirt and hence wash them away by using water. So this is the end of this video. In this video, I have given an introduction to the concept of surface tension along with some of its applications and consequences. If you have got any doubt in any of the topics discussed in this video, please do comment in the section below this video. Thank you.